James Webb Space Telescope has revolutionized the way we look at the universe in less than a year. Since its launch on December 25, 2021, multiple images captured by the largest telescope with potentially the highest infrared resolution and sensitivity have been going viral around the globe. The James Webb is no doubt the most advanced telescope in human history. The telescope's Integrated Science Instrument Module, or ISIM framework, provides it with electrical power, computing framework, cooling capability, and structural stability. The ISIM also holds the 4 science instruments and the guide camera of the telescope. The infrared imager NIRCam serves as the observatory's wavefront sensor, while the NIRSpec performs spectroscopy over the same wavelength range as that of the NIRCam. The mid-infrared instrument measures the mid to long infrared wavelengths, and the fine guidance center, a near-infrared imager and slitless spectrograph, is used to stabilize the line of sight during the science observations. So far, the images and data received from the JWST are well worth the $10 billion spent on building this miraculous invention. The first ever in ages from the telescope was revealed to the world on July 12, 2022, and experts believe these pictures from the largest and most powerful telescope in the world demonstrate Webb at its absolute best, fully prepared to further unravel the infrared universe. These included images of cosmic cliffs in the Carina Nebula, exoplanet WASP 06b, Southern Ring Nebula, Stephan's Quintet, and the brilliant deep field view of the universe. But these were just the first batch. Since then, the James Webb Space Telescope has provided scientists with even more dazzling and awe-inspiring images of the cosmos. Some of these images have left astronomers and cosmologists quite confused. A flood of astronomical papers has been published since the revelation of these images and data from the JWST. A few of these papers have incited panic among the cosmologists. But what exactly is the reason behind this wave of panic? Well, it's the assumption that the findings of the James Webb Space Telescope are blatantly and repeatedly contradicting the Big Bang Theory. In order to understand what's going on, we first need to understand what the Big Bang exactly is. The Big Bang is the prevailing cosmological model that explains the evolution of the observable universe. It was developed from observations of the structure of the universe and from theoretical considerations. It explains how the universe expanded from an initial state of high density and temperature. This model offers a comprehensive explanation for a broad range of observed phenomenon, including the abundance of light elements, large-scale structure, and cosmic microwave background. It is compatible with the Hubble-Lemaitre law, which proposes that the farther away a galaxy is, the faster it is moving away from Earth. The theory describes an increasingly concentrated cosmos preceded by a singularity in which space and time lose meaning. According to detailed measurements of the expansion rate of our universe, the Big Bang singularity is estimated at about 13.787 plus or minus 0.02 billion years ago, which is also the approximate age of the universe. The concept of the Big Bang is quite simple and easy to understand. However, the Big Bang is considered quite a misleading name for the expanding universe. The name conveys the idea of a firecracker exploding at a particular time and a place with a center. But the infinite universe is actually expanding into itself, and the universe doesn't have a center. The Big Bang actually happened everywhere at once. It was a process occurring in time, not a certain point in time. This is justified by the galaxies rushing away from each other and not from a particular central point. And we see the heat left behind from these earliest times, which uniformly fills the universe. And as much as we'd like to see it, the Big Bang is not something we can see, but that doesn't mean there are no observable signs of it. According to scientists, we can visualize the heat that was there about 380,000 years ago. This heat covers the entire sky and fills the universe around us. NASA and the ESA were able to map it out using satellites called the Cosmic Background Explorer, the Wilkins Microwave Anisotropy Probe, and Planck. At this point, the universe was extremely smooth with only tiny ripples in temperature. The JWST was designed to see a period of the universe's history that we have not yet seen before, instead of seeing the beginnings of the universe. The Cosmic Background Explorer, the Wilkins Microwave Anisotropy Probe, and Planck have all seen further back than the James Webb. The main purpose of the James Webb Space Telescope is to visualize the first objects that formed as the universe began cooling down after the Big Bang. According to Dr. John Mather, a senior project scientist for the James Webb Space Telescope, that time period is perhaps hundreds of millions of years later than the one the other satellites were built to see. Dr. Mather thinks that the tiny ripples of temperature that these satellites observed were the seeds that eventually grew into new galaxies. What humanity doesn't know is how and exactly when the first stars and galaxies formed in the universe, and this is the question the James Webb Space Telescope was built to answer. So to summarize, the Big Bang Theory is the leading explanation for how the universe began, and in its most simple form, it says that the universe as we know it started with an infinitely hot and dense single point that inflated and stretched, initially at unimaginable speeds and then at a relatively measurable rate over the next 13.8 billion years to the still expanding cosmos we see today. So far, the Big Bang is our best guess about the origins of our universe, but now it seems that these new images from the JWST are making some scientists doubt the credibility of this theory. The Big Bang Theory has been defended for multiple decades as an unquestionable truth by most cosmological theorists, but the new data from the JWST is making ones like Alison Kirkpatrick panic. She is an astronomer at the University of Kansas in Lawrence, and according to her, the latest revelations have made her question whether everything she's done in the field is wrong. The incredibly small, smooth, old, and surprisingly numerous galaxies are completely incompatible with the Big Bang hypothesis, in the opinion of a few scientists. The Big Bang proposes that the universe is expanding and a strange optical illusion must exist in outer space. Galaxies and other objects in the expanding space do not continue to look smaller with the increasing distance. Beyond a certain point, they start getting bigger, as their light is supposed to have left them when they were close to us. But the images of the JWST show them getting smaller and smaller. Even the galaxies with much greater luminosity and mass than our own Milky Way appear 2 to 3 times smaller in these images. In other words, the galaxies the JWST is showing us are the same size as the galaxies near us, indicating that the universe isn't expanding and that redshift isn't proportional to distance. The newer galaxies in the images have a redshift that is 2 to 3 times greater. This strongly contradicts the theory of an expanding universe, in the opinion of Eric Lerner and Ricardo Scarpa, but aligns with their prediction that we are part of a non-expanding universe. They had previously published results based on Hubble Space Telescope images that showed galaxies have a redshift all the way up to 5 that matched the expectations of non-expanding ordinary space. They were confident that the James Webb would only confirm their hypothesis. Big Bang theorists had expected to see badly mangled galaxies scrambled by multiple collisions and mergers. However, the JWST images actually showed overwhelmingly smooth disks and neat spiral forms, just like we see in today's galaxies. The data in the Panic article shows that there were around 10 times more smooth spiral galaxies than predicted, and this challenges our ideas about mergers being a very common process. According to Lerner and Scarpa, this data utterly destroys the merger theory. The Big Bang theory implies that the most distant galaxies in the James Webb images are seen as they were about 400 to 500 million years after the origin of our universe. But some of the galaxies have shown stellar populations that are at least 1 billion years old. Now, according to the Big Bang theory, nothing could have originated prior to it, so the authors of the Panic article believe that the existence of these galaxies is proof that the Big Bang didn't occur. And just as there must be no galaxies older than the Big Bang, so theorists expected that as the JWST looked out further in space and time, the galaxies would become fewer and eventually there would be none left, signifying a dark age in the cosmos. But a paper yet to be published demonstrates that galaxies as huge as the Milky Way are common even a few 100 million years after the hypothesized Big Bang. From the Big Bang standpoint, the distant galaxies are supposed to be intrinsically smaller. One galaxy noted in the papers is GHZ2, and it is far more luminous than the Milky Way and yet is calculated to be just 300 light-years in radius. This is 150 times smaller than the Milky Way. And the JWST images aren't the only reason the Big Bang theory may be considered wrong according to Lerner. He believes that right now the Big Bang makes 16 wrong predictions and only one that is correct. Its prediction of helium is off by a factor of 2. The prediction for the abundance of lithium is off by a factor of 20. And besides the absence of larger and more distant optical illusions, there is also the existence of large-scale structures too big to have formed in the time since the Big Bang. Most cosmologists and astronomers have stated that there's an explanation for every doubt Lerner and Scarpa's article has raised. The Big Bang is definitely not dead, and the recent observations of the JWST haven't disproven the theory. These observations have revealed some unexpected and strange things about the universe, but that's all. The Big Bang is centered around two facts. First, that more distant galaxies have a higher redshift than closer ones, and second, that the universe is filled with a cosmic background of microwave radiation. These constitute two of the three pillars of data supporting the Big Bang theory, the third one being the relative abundance of elements in the early universe. But these are just the foundation of the model. In past years, scientists have expanded on these to create the standard model of cosmology, also called the LCDM model. Everything from acceleration of cosmic expansion to the clustering of galaxies support this model. The Tolman test predicts that if the universe was non-expanding and static, the surface brightness of all the galaxies would be the same regardless of the distance, which isn't the case as evident by the JWST images. The distant galaxies have a dimmer surface brightness than the closer ones in these images. It is a common misconception that redshift proves that galaxies are speeding away. They aren't in reality. Distant galaxies aren't speeding through space. In fact, space itself is expanding and thereby putting greater distance between us. This subtle difference emphasizes that the galactic redshift is a result of cosmic expansion and not relative motion. Experts aren't denying that what the James Webb Space Telescope found doesn't entirely align with their predictions, but astronomers were hoping to find this sort of puzzling data. They believe that is the reason why so much was invested in building the James Webb Space Telescope in the first place, and they understand that the data collected by this magnificent telescope doesn't tell us that the Big Bang model is wrong, but some of their assumptions about it could be. The largely publicized attempt to discredit the Big Bang isn't the only thing triggered by the James Webb Space Telescope images. There's more, and this is actually good news. Just a few weeks after the first images of the JWST were made public, the telescope found a galaxy that existed about 13.5 billion years ago. The glass Z13 galaxy dates back to around 300 million years after the Big Bang, which is 100 million years earlier than anything previously identified. Rohan Naidu of the Harvard Center for Astrophysics has said that we're potentially looking at the most distant starlight that anyone has ever seen. It was spotted in the so-called early release data from the James Webb's NIRCam. After translation from infrared into visible spectrum, it looks like a blob of red with white in its center as a part of the wider image of the distant cosmos known as the deep field. The scientists analyzing the data from the James Webb have found out that this galaxy is the mass of 1 billion suns, and it is quite a surprising feature that they do not understand, but they're looking forward to finding out more once the Webb's managers give them telescope time to carry out spectroscopy. Do you think there are even older galaxies out there, and are Lerner and Scarpa onto something with their theory of the non-expanding universe? Tell us in the comments below.